So now we will start looking into the examples of signal flow graph. So this is the first question. How do we construct a signal flow graph from the given set of equations? So you have 6 equations here. One is y2 equal to a1 to y1 plus a4 to y4, y3 equal to a23 y2 plus a53 y5. Similarly, you have other 3 equations for which we need to construct a signal flow graph. So when you have this kind of question, the first thing is you need to identify the nodes and you have to identify the branch gains. So if you observe here, first equation y2 is a node which is equal to sum of the two incoming signals. One signal is coming from y1 which is having a gain a12. The other signal is other signal is coming from y4 which is having a gain a42. Similarly, y3 is a node wherein a signal having a gain A23 is coming from Y2 and A53 is coming from Y5. So first what we need to do is we have to look into the number of nodes and we have to see the number of branches over here. So if you look into the equations, you have nodes Y1 up to Y6. That means we have 6 nodes. Y1, Y2, Y3, Y4, Y5 and Y6. So totally we have 6 nodes here, and if you consider the branch gains, we have A12, A42, A23, A53, A34, A45, A35 and A56. So totally 1, 2, 3, 4, 5, 6, 7 and 8. So totally in this equations which we will construct the signal flow graph has 6 nodes and 8 branches. So now we'll proceed how to construct a signal flow graph. So we have to identify each of the branches separately, then we have to combine. So usually what we do is we construct a signal flow graph separately for each equation and then we club it. So this is given detailed in the notes which has been circulated. So now we'll see how to construct a signal flow graph from this. So this equations I already have it here. So first thing what we need to do is we will represent the 6 nodes. So we have to represent 6 nodes: y1, y2, y3, y4, y5 and y6. So we will name the nodes y1, y2, y3, y4, y5 and y6. This is how first we have to represent each of our nodes. Then we'll look into our first equation. Our first equation is y2 equal to a1 to y1 plus a4 to y4. That means the signal which is coming at y2, one is from y1 and the other one is from y4. That is what it tells. And you see the branch gains. Y2, we have to draw the arrow mark this way because A12 into Y1 is the incoming signal for Y2. Likewise, A42 into Y4 is the incoming signal for Y2. So this gain we will represent it as A12 and this gain is A42. Now we will look into our second equation, y3. y3 is a23 y2. So from y2 to y3 we will have one branch. The other signal comes from y5. So from y5 we will draw one more signal. Yes, one more branch. So y3 is equal to a23 y2. That means like this, the arrow mark from y5 also it is going to y3. So our arrow mark will be this direction. So now we will represent A23. This is A23 and here is A53. Right? The third equation, y4 is equal to A34y3. So y4 is A34y3. It is A34y3. Next, we have y5 is equal to A45y4 plus A35y3. That means at y5 you have two signals which is incoming. One is from y4 and the other is from y3. So from y3 you have one more signal which is coming to y5. Now what is the gain of this? So this gain is A45 and this gain is A35. This is our gain. So the last equation is y6 is A56 into y5. So our gain is A56 into y5. So this is our input node. This is our output node. So this is how we construct a signal flow graph. Hope this is clear to you. So likewise, we can construct any signal flow graph provided you should be able to identify the nodes. You should be able to identify the direction of the arrow. That is most important. So now if you look, this graph which we have constructed is already over here. This is the same graph which we have plotted for this particular set of equations. So this is the 6 differential equations which is given with set of algebraic equations, and we have constructed a signal flow graph for this. So this is your final signal flow graph. So we'll start with the problems of signal flow graph to obtain the transfer function. So to obtain the transfer function for a given signal flow graph, we need to apply Mason's rule or Mason's gain formula. So the first question, apply Mason's rule to calculate the transfer function of the system represented by the following signal flow graph. So this is the signal flow graph. This is the signal flow graph which is being given. So you have the input node which is R, the output node will be C. So now we'll look into how to obtain the transfer function for this particular question. So I have my question over here, the same question. So now we will start analyzing this particular signal flow graph to obtain the transfer function. So to find any transfer function, first you have to identify the input node and output node. In our particular problem over here, R is the input node and C is the output node. R is the input and C is the output node. These are the two nodes. And if you find you have a node over here, you have a node at this point, you have a node here, you have a node at this point. So other than the input node and output node, you have 4 nodes. If you want, you can name the nodes or need not name the nodes. So it is left to you. So we have this signal flow graph. The first thing what we have to do is we have to find the forward paths. So first we'll find the forward paths for this. So you have to write the forward paths. So you have to identify the forward paths. So forward path is the signal should flow from input to output. So you know input is R, output is C. So if we look here, this is the first direction. This is the first path. And this is our second path. So first path which is indicated in blue, the second path which is indicated in orange. Now we have to write the path gains for this. We have to write the path gains. So the blue line one, we will indicate it as path P1. Okay. The gain of it is 1 into G1, G4 into G2 into 1 into 1. That means our path gain for the first path is G1, G4 into G2. Path gain for the first path is G1, G4, G2. Likewise, path gain for the second path is G1, G4, G3. P2 is G1, G4 and G3. So this particular problem has only two forward paths. So firstly we will write down the path gains which is P1 and P2. Next is to identify the loops. This particular problem doesn't have any self loops. It doesn't have any self loops. Now we have to find the individual loops. So the loop we will notate it by L, capital L. So the loop gains, the first loop gain, we will identify the first loop gain. So our first loop is this. Our first loop gain is this particular portion. So it is from this path in this way. That is our first loop. So we'll write that as L1. L1 is having a gain G1, G4 into H1. This is our first loop gain. L1 is G1, G4 into H1. Our second loop is loop gain L2 is G1, G4, G2 into minus H2. G1, G4, G2 into minus H2 is our second loop gain. Okay. Next is the third one. So next is third loop, which is this particular loop G1, G4, G3 into minus H2. So our third loop gain L3 is G1, G4, G3 into minus H2. So this is our third loop gain. So you have all the loops over here, 3 loops. L1 is G1, G4, H1. L2 is G1, G4, G2 into minus H2. L3 is G1, G4, G3 into minus H2. So these are the three individual loops. There are no self loops. Now we have to see whether there are any non-touching loops. Non-touching loop means the two loops. Say we have now three loops, L1, L2, L3. Any two loops should not have any common node. That is non-touching loop. So here if you observe, all the loops have this particular node as common. That's why we don't have any non-touching loops. So there are no non-touching loops. So hope this is clear to you. So we have identified the forward paths. There are two forward paths. There are no self loops. There are no non-touching loops. And we have three individual loops. Now we will use the Mason's gain formula to obtain the transfer function for this particular problem. So the Mason's gain formula is T is equal to C of S by R of S is equal to summation I is equal to 1 to N Pi delta I divided by delta. Pi delta I divided by delta. Now N is the number of forward paths. So I is equal to 1 to 2. So our formula becomes T equal to P1 delta 1 plus P2 delta 2 divided by delta. So P1 delta 1 plus P2 delta 2 by delta. You know what is P1, you know what is P2. Now we have to find what is delta, what is delta 1, what is delta 2. Always first you have to write what is delta, and from that delta we will write what is delta 1 and what is delta 2. So our delta is 1 minus sum of all individual loops. Plus sum of two non-touching loops minus sum of three non-touching loops, etc. So it goes on. Since we don't have any non-touching loops, our formula will end up with this. We don't have any non-touching loops. That's why we can, for this particular problem we can write 1 minus just sum of all individual loops. So we have three loops. So we'll write delta is equal to 1 minus, we have named the loop as L1 plus L2 plus L3, and we have to write the loop gains here. It is 1 minus, what is L1 you have to substitute, what is L2 you have to substitute here, what is L3 you have to substitute here. That will be your delta. So hope this is clear. Now from this particular delta we'll write what is delta 1. Delta 1 means, say now we have three loops L1, L2, L3, and for delta 1 means we have to consider the forward path 1. We have to see which of the loops is not touching first path. We have to see L1, out of L1, L2 and L3, which particular loop is not touching the forward path 1? That is delta 1. So delta 1 equal to 1 minus whether L1 is touching first path? Yes. Whether L2 is touching the first forward path? Yes. Whether L3 is touching the first forward path? Yes. So if you look into this, you can clearly see our first loop, our second loop, our third loop, all are touching the first forward path. So the yellow one is the first forward path, all the red ones are the loop. So all our loops is touching path P1. That's why our delta 1, which is 1 minus L1 plus L2 plus L3, all the loops are touching path 1. So this becomes 0. So delta 1 is equal to 1 minus 0, which is equal to 1. Next, delta 2 is equal to, again we will check our signal flow graph. We have this first loop, we have the second loop, we have our third loop, all are touching our second forward path. So yellow again is the forward path, red is the loop. So we can see that all the three loops are touching the second forward path. Therefore, our delta 2 becomes 1 minus 0 again, which is equal to 1. So we have found P1, P2, delta 1, delta 2 and delta. Next is to write the transfer function. So our transfer function T is equal to P1 delta 1 plus P2 delta 2 divided by delta. By substituting all that, you will get G1, G4, G2 plus G2 plus G1, G4, G3 divided by 1 minus G1, G4, H1 minus G1, G4, G2, H2 minus G1, G4, G3 and H2. So this is our transfer function. So all of you need to solve this problem and see, this is the easiest of all. So this is the particular transfer function. Transfer function is G1, G4, G2 plus G1, G4, G3 divided by 1 minus within the bracket G1, G4, H1 minus G1, G4, G2, H2 minus G1, G4, G3, H2. So this is our final answer. This is how you have to arrive at the transfer function. So now we will move on to the next particular problem. So apply Mason's rule to calculate the transfer function of the system represented by the following signal flow graph. So now we will look into the forward paths first and then we will look into the loops. So if you look here, your input node is x1, output node is x8. Input node is x1 and output node is x8. And you can clearly see that the forward paths are G1, G2, G3, G4. This is our first forward path. And our second forward path is G5, G6, G7 and G8. This is our second forward path. So our input is x1, output is x8 node. The first forward path has again G1, G2, G3, G4. Second forward path has again G5, G6, G7 and G8. And there are no self loops. There are no self loops. And we need to identify the individual loops. So we need to identify the individual loops. So the individual loops are, this is our first loop, this is our second loop, this is our third loop, and this is our fourth loop. So we will name it L1, L2, L3, L4. So these are our individual loops. L1, L2, L3 and L4. So with this, first we will write the forward path gain. We will write the individual loop gains. Since there are no self loops, no problem. Next we have to find the non-touching loops. So here it is clear that L1 and L2 has a common point x6, common node x6. Therefore L1 and L2 cannot be non-touching loops. Next is this L1 is non-touching with L3. Similarly, L1 is not touching with L4. So L1, L3, L1, L4 can be non-touching loops. Similarly, L2, L3, L2, L4 can be non-touching loops. So I repeat, L1, L3, L1, L4, L2, L3, L2, L4. These are the non-touching loops. L1 and L2 cannot be because x6 is common. L3 and L4 also cannot be since x3 is in common. So with this, we will write the path gains, we will write the loop gains, we will write the non-touching loops, and finally arrive at the transfer function. So we had two forward paths for that particular problem. So we'll write the forward path gains P1. P1 is G1, G2, G3, G4. P1 is G1, G2, G3, G4. P2 is G5, G6, G7, G8. So P1 is G1, G2, G3, G4. P2 is G5, G6, G7, G8. There are no self loops. Next is to identify the individual loops, which we have identified as 4. L1, L2, L3 and L4. So loops L1 has a gain G2H2, L2 has again G3H3. L3 has again G6H6. L4 has again G7H7. Clear? G7 and G7 and H7. So L1 is G2H2, L2, L3 and L4. So we have written all the individual loop gains. Then comes our non-touching loops. Non-touching loops. So this non-touching loops, our pair was L1, L3, L1, L4, L2, L3 and L4, L2. So our combination was L1, L1, L3, L1, L4, L2, L3 and L4, L2. These are the pair of non-touching loops. So with this, we will write the transfer function. These are two non-touching loops. We don't have any three non-touching loops in this particular problem. So first we will write the delta. So transfer function t is equal to, since we have two forward paths, it is p1 delta 1 plus p2 delta 2 divided by delta. First we have to write what is delta. Delta is equal to 1 minus sum of all the individual loops. So you have 4 L1 plus L2 plus L3 plus L4 plus sum of two non-touching loops. So our non-touching loops is L1 L3 plus L1 L4 plus L2 L3 plus L2 L4. These are our non-touching loops. So our delta equation is this. This is our delta. Now from this delta, we have to write what is delta 1 and we have to write what is delta 2. And you substitute in this particular problem, you are going to arrive it with the transfer function. So I want you people to substitute all this p1 delta 1, p2 delta 2 and obtain the transfer function and let me know the answer. So we'll find what is delta 1. So delta 1 means which loops doesn't touch forward path 1. That is our main thing. So our first forward path is this G1, G2, G3, G4. So we have to see which loop is not touching first forward path. So clearly it is seen that L3 and L4 doesn't touch the first forward path. So L3 and L4 doesn't touch the first forward path. Therefore, our delta 1 becomes 1 minus L3 plus L4. So all other things we will discard. That is L1, L2 combination things, everything we are going to discard. So we will retain 1 minus L3 plus L4. So again if you see Here the second forward path, which is our G5, G6, G7 and G8, L1 and L2 is not touching. So therefore our delta 2 becomes 1 minus L1 plus L2. So it becomes 1 minus L1 plus L2. So this is delta. You have delta 1. We will look into this next problem, that is to find the transfer function C of S by R of S for the signal flow graph. So again we can observe that our R of S is the input, C of S is the output. R of S is input, C of S is output. Other than that, we have different nodes in this. So if you look into this particular signal flow graph, we can observe that there is only one forward path. There is only one forward path with gain G1, G2, G3, G4, G5. I'll discard that G1 of S. I'll just write G1, G2, G3, G4, G5. You have to write it as G1 of S into G2 of S into G3 of S into G4 of S and so on. So our first path gain is that. So we don't have any other forward paths. So we have only P1. Next is to identify the loops. Here again you don't have any self loops. There are no self loops in this. So, next we will identify the individual loops. So to identify the individual loops, it is clear that from this point again it enters here. So G2 into H1 is one loop. G4 into H2 is another loop. G7 into H4 is the another loop. And we have the third loop, which is biggest of all. That is starting from G2, G3, G4, G5, G6, G7, G8 back to this point. So we have 4 loops, that is L1, this is L2, this is L3 and the last one is L4. L1, L2, L3 and L4. So first we will write down the forward paths and we will write down the loop gains. Later on we will look into the non-touching loops. So we had we had only one path in this particular example. So the path gain is P1 equal to G1, G2, G3, G4, G5. P1 is G1, G2, G3, G4, G5. We had identified 4 loops with loop gain L1 equal to G2H1, L2 equal to G4H2, L3 equal to G7H4, L4 equal to G2, G3, G4, G5, G6, G7, G8. This is our path gain and individual loops L1, L2, L3 and L4. This is H4. So next we will look into 2 non-touching loops, 3 non-touching loops. These are the individual loops. Individual loops. So next we will look into 2 non-touching loops. 2 non-touching loops. So if you look here, L1 and L2 are not touching. L1 and L3 are also not touching. L2 and L3 are not touching, but L4 is touching all the other loops. So our two non-touching loop combination is L1 L2, L1 L3, L2 L3. So those are the non-touching loops. So two non-touching loop combination is L1 L2, L1 L3, L2 L3. So these are our 2 non-touching loops. So we have to check whether there are any 3 non-touching loops. We have to see that combination also. So we'll see whether there are any 3 non-touching loops. So if you can see, it is clear that L1, L2 and L3, these 3 are not touching. 3 non-touching loops you have. So L1 is not touching with L2 as well as L3. So these are the 3 non-touching loops. So we don't have any other combination. So our 3 non-touching loops are L1, L2 and L3. So now we will write on to our delta and delta 1. We have to write LP1, delta and delta 1. So we'll write delta first. So delta is equal to 1 minus individual loops. We had 4. So L1 plus L2 plus L3 plus L4. Plus, I'll write it here, plus sum of non-touching loops, L1 L2 plus L1 L3 plus L2 L3 minus sum of 3 non-touching loops, that is L1, L2 and L3. So this is our delta. From this delta we have to write what is delta 1. So delta 1 should be 1 minus, that is this 1 minus which of the loops are not touching to the first path. We have only one path. So which loops are not touching to the first path. Here it is clear that L1 is touching first path, L2 is also touching first path, L4 is also touching first path. But our L3 is not touching the first path. So our delta 1 turns out to be 1 minus L3. All other combination which has L1, L2 and L4, all other combinations which we have L1, L2, L4, we have to discard. So delta 1 is 1 minus L3. So substitute T equal to C of S by R of S equal to C of S by R of S T equal to C of S by R of S is equal to P1 delta 1 divided by delta. Substitute this P1 delta 1 by delta and obtain the answer. So these two answers you have to obtain it and write it in your notes.